Hi, welcome to class once again. I remain Olujimi Gabriel. Today we shall be discussing crystalline structure, the backbone of crystalline solid. Here are the brief introduction of crystalline. Crystals are solids with a repeated 3D arrangement of particles. What do we call 3D? That is three dimension, X, Y, and Z axis. That is like a rectangular cube. Two, found in nature and synthetic material, e.g., diamond and salt. More of the reason why it is almost impossible to mistaking salt for sugar because of their crystalline nature. Importance determine the physical and chemical properties of substance. How a substance, the hardness of a substance and the softness is determined by the physical and the crystalline structure. Now, what is crystalline solid? They are well ordered, have definite arrangement of molecules or atoms or ion. Now look at this diagram very well. Now taking one portion of this diamond out, this is the structure of the molecules that made up this diamond. You can see it is a well arranged, repeated 3D pattern. Now what are the components of crystal? The first one is the lattice point. That is their fixed position of what? Particles. Then a unit cell. That is the smallest building block of a lattice. Now look at this heading now. We have crystal lattice and unit cell. This one is a unit cell. This one form one part of a crystal lattice. Now, by the time you have like six of these, it will form another giant molecule of the same shape. That's why we call it what? A unit cell. Now, then the symmetry. We have govern the pattern of what? Repetition. That's what we call the symmetry. By the time you take one part out, it will be exactly the same thing we have from the other part. Now, look at this object now. If you remove this block now, it's just the repetition, the replica of the whole shape. That's what we call the symmetry. Now, type of unit cell. We have many other unit cell, but we just have to limit our scope of knowledge to this part because they are more higher substance with other type of unit cell. By the time we get to material science. The first one is simple cubic, that is SC. That is, we have atom at the corners. Now, imagine you have a dice or a cube. Now, atom is now attached to every corner, every four corner of the shape. Now, we have the body center, that is the BCC, atom at the center. Apart from the one you have at the corner, you now have one at the center of the cube itself. We call it body center. Then we have the face center cubic, that is the FCC. The FCC, atom at the corner and at the center. That is, apart from the atom at the corner, we now have one at each face of the cube. Now, look at it here. This is simple cubic. Look at atom at every corner of the cube. Now the second one, this is FCC, that is face center. Apart from all those one at the corner, you now have one at every face of the cube. Now the third one is, apart from the one at the corner, you now have one at the center of the cube itself. Now these are example of these are how the molecule looks like. You want have one big one molecule at the center. You have one at every face. Look at it here. Every face here. Now this one you have just at the corner of it. Now we have another substance which we call non-crystalline. Since we have crystalline substance, those ones they have well arranged repeated pattern. But for the non-crystalline, they are also called amorphous solid. Lack a long range order in their atomic structure and have disordered arrangement of atom. You can see this one they are randomly arranged unlike the crystalline structure. Example of material that will exhibit this is glass, plastic, and other material. Look at, we call them amorphous substance. Look at, this is a glass. You can see the way they are arranged. They are not repeated. They are just randomly arranged. These are the material we use in making glass. We have the sodium, silicon, and oxygen. Now, when we compare material, that is crystalline material and non-crystalline material. Now, this one, they are fashioned in three-dimension pattern, but this one, they are just randomly arranged. So we call them amorphous substance. Now, the strength of the material are relatively high. This one, their strength is lower compared to this. That's why diamond is considered to be the hardest substance ever. It can cut glass, anything. Now, strength of this material are lower than crystal material. Example are metal and alloys. Now, this one are glass, wood, plastic, rubber. That's why when you eat this one, they behave in a in a funny way. But when you eat this one, they can form block, they can form liquid again and back to where it is. Now, look at the pattern, look at the different pattern that they possess. You can see this one, they are well arranged. You can see this one has hexagonal in shape here. By the time you have hexagonal shape here, you have another shape here. They are not well arranged at all. More of the reason why, if the windshield of a glass of a car is broken, you see they form some sort of grain, like grain of corn or bean like that, because of their crystalline, non-crystalline nature. Now, application. We use them crystallized solid for gemstones like diamond, rubies, then sapphires, used in jewelry for their beauty and hardness. Then in semiconductors, the silicon, the germanium, and arsenide. These are what we use. Essential for electronic devices such as transistor and microchips. Microchips, they now make the work easy, then the world easy now, as you can solve more data in a tip of a size of a needle because of semiconductors. Then we have salt, sodium chloride used in seasoning, preservation in food, and as well as the icing the road. So the application. Thank you for your time. Till I come your way next time, have a lovely day.